Hey everyone, today we're going to talk about the product rule for differentiation. And the first step is to describe the product rule for differentiation and then to go through a few examples using the product rule. So first off, the product rule. If f and g are differentiable at x, then so is f times g, and the derivative of f times g is just the derivative of f times g plus f times the derivative of g. So, in turn, to take the derivative of f times g, you've got to incorporate both the derivative of f and g and the values of f and g at that point. So, for example, if we'd like to differentiate y equals 3x plus 4x minus 8 times 7x plus 3/4, we could multiply everything out and collect like terms, and then just use our power rule in the distribution of the derivative across sums and products. But, just as a demonstration for the product rule, dy dx would be given by the derivative of the first, or what we called f, so the derivative of 3x squared plus 4x minus 8 times the second, 7x squared, no square, just 7x, plus 3/4, plus the first, 3x squared, plus 4x minus 8, times the derivative of the second, so 7x plus 3/4. Then we just use our appropriate derivative rule. So the derivative of the first with respect to x is 6x plus 4 times the second, which is 7x plus 3/4, plus the first, times the derivative of the second. And the second was just 7x, so its derivative is 7. At this stage, you could combine like terms and simplify if necessary, but in the end, that's the derivative of the product. So let's look at a slightly more complicated example where we have 3x squared times sine x, and we're looking to find the second derivative. So the first thing is to find the first derivative. Notice the name of the function is f of x, so maybe I'll use first and second for 3x squared and sine x. So f prime of x will be the derivative of the first. Derivative of 3x squared is 6x times the second, which is sine x, plus the first, which is the 3x squared, times the derivative of sine x, which is cosine x. And then in order to find the second derivative, we just need to take the derivative of the derivative. Notice we're going to have to use a product rule twice. There's the product rule on that expression, and then the product rule on that expression. So the derivative of 6x is 6 times the second, plus the first, which is 6x, times the derivative of the second, which is negative cosine x. Then we'll come along and differentiate the second term, again using the product rule. So the derivative of 3x squared is 6x times the second, plus the first, the 3x squared, times the derivative of the second. The derivative of cosine x is minus sine x. And then we just go and try and collect some like terms. And you can collect terms in a number of ways, but I'm just going to collect them in terms of the trig functions. So there are 6 minus 3x squared sine x. I got that from the 6 sine x and the minus 3x squared sine x. And then similarly, if you look at the cosine x terms, there is minus 6 cosine x, and that cancels with the plus 6 cosine x. So that is our final answer, 6 minus 3x squared times sine x. And then last but not least, we'll look at something that has not only a product, but with it a chain. You could see that the x squared plus 1 is being raised to the 5th, so that's a chain rule. And the cosine, we rewrite this as being raised to the 8th. So we'll have to use the product rule and the chain rule. So that dy dx, when we apply the product rule, is the derivative of the first, which is 5 times x squared plus 1 to the 4th times the derivative of the inside. Derivative of x squared plus 1 is 2x, times the second, which is cosine to the 8th of x. And to that, we're going to add on the first, x squared plus 1 to the 5th, times the derivative of the second, again applying the chain rule, and that is 8 cosine of 7x, and the derivative of cosine is negative sine. And then now we just simplify as much as we can to get in the first term 10x x squared plus 1 to the 4th cosine of 8x. And then in the second term we get minus 8 x squared plus 1 quantity to the 5th. And there's a sine x, and there's a cosine to the 7th. So as bad as that may look, that is the most simplified version that we'd be able to get. So that brings us to the end of our video of the product rule, where we described the product rule for differentiation, and we showed 3 examples of using the product rule. Thank you very much, and have a great rest of your day.